In this section, we're going to learn about Hamilton paths and Hamilton circuits. Those are paths that pass through each vertex of the graph exactly once. Okay, so this time we're going a little bit further than we did with an Euler path or an Euler circuit. In those, we did the edges once, and this one we're going to do the vertex once. So if it passes through, it's called a Hamilton path. If you begin and start at the exact same vertex, then it is called a Hamilton circuit. So let's look at some. On this one, it says find a Hamilton path for the graph and then find a Hamilton circuit. So for the first one, they started at A, then they chose to go to B, C, D, and E. That would be a Hamilton path. Now, if I wanted to make that a circuit, that's the only time you can hit that vertex twice, is when you're going to begin and end with the same vertex. So if I had added one more on there from E to A, then I would have what's called a Hamilton circuit. We visited each vertex once, but we started and ended with the same one. So that one we visited twice. Now, to have a Hamilton path or circuit, you must have, or to have a circuit, I should say, you must have a complete graph. And to get a complete graph, then you have to have an edge between each pair of vertices. So this one is not complete. I don't have an edge from A to D, and I don't have an edge from B to C. This one would be a complete graph. Now, the reason that's important is if you have a complete graph, you can figure out the number of Hamilton circuits. How many will it have? Here's how you do that. You take the number of vertices, we call that n. You do n minus 1 factorial. Now, if you haven't done factorial in a little bit, let's explain what that means. N is your number of vertices. So if you have 4 vertices, 4 minus 1 factorial would give you 3 factorial. That means you start at 3, then you go down by 1. 3 times 2 times 1. That's going to tell me there are 6 Hamilton circuits. Let's say I had 5 vertices. Okay, I would do 5 minus 1 factorial. That give me 4 factorial. And that would be 4 times 3 times 2 times 1. And that would tell me there are 24 different Hamilton circuits. So in the next example, it says, if you look at this, this is a complete one. One circuit is A to B to C to D to A. Okay, that would be a circuit. We started with A, ended with A. What they want you to understand is if you start with B and then go B, C, D, A, B, that's the exact same circuit. Okay, you're doing the same path, you just started at a different spot. Same thing with C, D, A, B, C would be the same circuit. Says in order to avoid duplication when you form circuits, you should always assume that you begin with A and end with A. Okay, so there are 6 different unique Hamilton circuits for the graph we were just looking at. All right, for this one it had 4 vertices, so we do 4 minus 1 is 3. 3 times 2 times 1 gave us 6. There are 6 different circuits for that graph, 6 different unique ones, and here they are listed down at the bottom. Okay, so each of these starts with A and ends with A, but it can be written in different ways. Now we can also talk about this when we talk about weighted graphs. Okay, sometimes all edges are not the same. So a complete graph whose edges have numbers attached are called weighted graphs. The numbers shown along the edges are called the weights. So let's look at a weighted graph. Here's our same graph, but this time they gave us weights for each one. Says the graph below is a model of the graph for one-way airfares from cities A, B, C, and D. Use the weighted graph to find the cost of a trip for the Hamilton circuit that goes from A to B to D to C to A. So from A to B is 190, and then we're going from B to D. Okay, that's 155. And then we're going from D to C. That's 179. And then C back to A. We've touched all of the vertices exactly once, except of course this last one. And that one is 124. When you add all that up, the cost of this trip would be $648.